Hello everybody, welcome to another mathematics presentation. So in this presentation we are going to answer questions on matrices, and these questions are picked from different past exam papers. So I'm going to start with our question 1 right here. Given that matrix B is equal to this matrix, Roman numeral 1, find the value of x for which the determinant of matrix B is a 22. Roman numeral 2, hence find the inverse of B. So we are going to start with finding the value of x. Okay, so what you are going to do is this. So let me just demarcate here so that I create enough space. So we are going to start with our first question. They are saying we need to find the value of x for which the determinant of this matrix B it's a 22. So in order for you to find the value of x, we are going to assume that you are finding the determinant of matrix B. So to find the determinant of matrix B, we get these diagonal elements, these major diagonal elements, the product, we multiply them, okay? So we are going to have 4 times negative 3x, then minus, we find the product of the minor diagonal elements, that will be x times negative 1. So x times negative 1, then we equate to the determinant of this matrix B, which is a 22. So this will be equated to 22. So from here, we are going to multiply 4 times negative 3x, and this will give us negative 12x, minus x times negative 1, this will give us negative x, is equal to 22. So from here, we are going to open the brackets right here. So we are going to write negative 12x, negative, positive x, equal to 22. So since we want to find the value of x, we are going to simplify on the left hand side. Negative 12x plus x. This will give us negative 11x equal to 22. So in order for us to just remain with x, we are going to divide both sides of the equation with the coefficient of x, which is a negative 11. Even here we divide with negative 11. So this and this will cancel. Therefore, x equal to 11 into 22, because there are 2 times. Now, because it was having a negative and this one is a positive, so this will be negative 2. So this is the value of x. Okay, so since we have found the value of x, let us now look at our second question. Hence, find the inverse of B. So this is our matrix. Now we are going to write the original one, whereby we are going to substitute where there is x with the value of x that we have found, so that we can have the original matrix. In this case, it's B. Okay, so we have 4. Here there was x, so the value of x is a negative 2. Here there is a negative 1. Here there was a negative 3x. So negative 3 times negative 2 to be give us positive 6. So here we are going to have a positive 6. So this is the original matrix for B. Now, how can we find the inverse of B? So the inverse of B is found by writing this formula, B inverse. So this is how we can denote the inverse of the matrix, equal to 1 over the determinant of matrix B times the adjoint of matrix B. So this is the formula. Now here, the determinant of matrix B have been given, which is 22. So we are going to write B inverse equal to 1 over 22 times. So the adjoint of the matrix is found by, you can see the original matrix. So to find the adjoint of this matrix, the major diagonal elements, they swap. So the 6 will be where the 4 is, the 4 will be where the 6 is. Then to these trading diagonal elements, we add the negative sign. So because this one is negative 2, it's going to be positive 2. Also this one is a negative 1, it's going to be a positive 2. So this is the adjoint of matrix B. Then from here, we just need to multiply, where I'll say B inverse equal to 1 over 2 times 6. This will be 6 over 22. Then 1 over 22 times 2. This will be 2 over 22. So I'm just multiplying everything. 1 over 2 times 2. Again, we are going to have 2 over 22. Again, 1 over 2 times 4. This will be 4 over 22. This is the matrix that we are getting. Now, we need to simplify this. So therefore, B inverse equal to, so we find the highest common factor of 6 and 22, which is a 2. 2 into 6, it's a 3. 2 2 into 22, it's 11. Highest common factor of 2 and 22, it's a 2. 2 into itself, it's a 1 over 11. Even here we have the same, 1 over 11. 4 and 22, the highest common factor is a 2. 2 into 4, it's a 2. 2 into 22, it's 11. So this is the inverse of matrix what? B. So this is our answer to our question 1. Okay, let us now look at our second question. So we now come to our question 2. Our question 2 reads, given that the determinant of matrix Q, so this is matrix Q, which is having the elements 2b minus 1, 4, negative 3b, negative 5. So the determinant of this matrix Q, it's a 15. Find the value of b. So we can see we have these variables, which is b. We need to find the value of b. Question B, find the inverse of matrix what? Q. So we are going to start with finding the value of b. Okay, so we write our question. So to find the value of b, since we have been given the matrix of this Q, we are going to do the same. We are going to find the product of the major diagonal elements. So we have 2b minus 1, then we also have a negative 5. So we find the product of this, which will be negative 5 times, okay? So negative 5 times 2b minus 1, okay? Then minus, we find the product of the trailing diagonal elements, which is 4 and negative 3b. So 4 times negative 3b, okay? Then we equate this to 15, okay? So I hope it's clear there. Alright, so we've now equated to 15. So we have found the product of the major diagonal elements, 2b minus 1, and then we multiply with negative 5, okay, here. Then minus the product of the minor diagonal elements, which is a 4 times negative 3b. This is what we have written. We equate to 15 because 15 is the determinant of this matrix. So from here, we can try to simplify. Negative 5 times 2b, this will give us negative 10b. Then negative times negative, it's a positive. 5 times 1, it's a 5. Then minus 4 times negative 3b, this will be negative 12b, equal to 15. Then from here, we are going to open the bracket. So write negative 10b plus 5, negative negative, positive 12b, equal to 15. Then from this stage, we are going to group the like terms together. So negative 10b, its like term is a plus 12b, okay, equal to 15, its like term is a plus 5. Now, when it comes this side, it will be a minus 5. Okay, so I hope that you are following. Then negative 10b plus 12b, this will give us 2b, equal to 15 minus 5, it's a 10. So we are going to divide by 2, even this side by 2. So we are going to cancel 2. We remain with what? A b, equal to 2 here 1, 2 into 10, it's a 5. 5 into 10, into 1 into 5, it's a 5. So this is the value of b. So now, since we have found the value of b, we can come back to our question. We can try to write now the original matrix for this one, which is matrix Q. It will be equal to, so here where we have 2b minus 1, where there is b, we are going to substitute with a 5, okay? So it will be something like this, 2, then times 5, then minus 1. So 2 times 5, it's a 10 minus 1, so this will give us a 9. So meaning that here we are going to have 9, then here we have 4, then here we have negative 5. Now here there is negative 3b, which is negative 3 times the value of b, it's a 5, which will give us negative 15. So here we are going to have negative 15. So this is the original matrix. So having known our original matrix, we can now find the inverse of matrix Q, this matrix. So this is what we are going to do. To find the inverse of the matrix, we say matrix Q inverse is equal to 1 over the determinant of matrix Q times the adjoint, okay, times the adjoint of matrix Q. So from this stage now, we are going just to substitute Q inverse equal to 1 over the determinant of Q have been given, which is a what? A 15 times. Then we find the adjoint of matrix Q. So this is matrix Q. The adjoint of this matrix, okay, Q equal to, remember what I've said? How do you find the adjoint? We swap these major diagonal elements, they will swap. You're going to have a negative 5 here. Then we are going to have a 9 right here. Then to these minor diagonal elements, we just add the negative sign. So this one is a positive 4. It's going to be a negative 4. This one is a negative 5. It's going to be, negative 15. It's going to be a positive 15. So this is the adjoint of matrix Q. So it's the one that we are just going to substitute right here. We put the adjoint, which is negative 5, negative 4. We have a 15. We have a 9. Okay. Then we just multiply everything. So we have Q inverse equal to 1 over 5 times negative 5. So we're going to have negative 5 over 15. 1 over 15 times negative 4. You're going to have negative 4 over 15. 1 over 15 times 15. This will give us 15 over 15. Okay. Then 1 over 15 times 9. This will give us 9 over 15. This is the matrix. Now we need to simplify it. So to simplify this one, 5 here, 1, 5 into 15, it's a 3. So remain with 1/3. Then this one, negative 4 over 15, just write it the way it is, negative 4 over 15. Then this one, 15 here, 1, 15 here, 1, 1 over 1, it's a 1. Then this one, we look for the highest common factor of 9 and 15, which is a 3. 3 here, 3. 3 into 15, it's a 5. So we have 3 over 5. So this is the inverse of matrix Q. So we have answered our 2 questions. We've come to the end of our lesson. Thank you so much, everybody, for having time to view this content. This has been your presenter, Mr. Mlenga. Bye-bye.